Today's topic is an introduction to unit rates. Your learning target says, I can calculate the unit rate from a story problem. Let's start with understanding what unit rate is. Unit rate always compares something to one. So for example, miles per gallon, or calories per serving, or cost per item are everyday uses of unit rate. Unit rate makes it easy to determine which item is the best buy or who is going faster. In order to calculate unit rate, you have to think about what you are trying to find. You can usually find this in the question part of the problem. So if it asks you to find miles per gallon or it asks you to find cost per item, you are going to look for that and then you are going to divide the quantities in the order that they come up. So let's see if we can apply this. Here's a story problem. It says you kick a soccer ball to your friend who is 13 and 5/10 feet away. Your friend receives it 2 seconds later. At what rate is the soccer ball traveling per second? Round your answer to the nearest tenth. So I've got two measurements here. I've got feet and I've got time. And so I have to know which order am I going to divide in. So I'm looking at what the question asks me. In essence, how far does it travel per second? So the travel is 13 and 5/10, and the seconds is 2. And on the previous slide, I said we were going to use division. So if you pick up your calculator and you take 13 and 5/10 divided by 2, you will get 6 and 75/100, which seems like a pretty good answer until you read the rest of this. It says round your answer to the nearest tenth. That is 1 decimal place. So right now I've got 2 decimal places and I need to cut off the second one. But I can't just discard it. I have to think about it. So if this number after my cut line is a 0, a 1, a 2, a 3, or a 4, I can just cut it off and get rid of it. But if it's a 5, 6, 7, 8, or 9, it means I want to round up. And because it's a 5, my answer is going to be 6 and 8/10 feet per second. Let's try again with this story problem. It says during the football game there were 5 touchdowns in 15 minutes. Based on this information, how many touchdowns per minute were scored? Round your answer to the nearest hundredth. So I'm looking in the question and it's going to tell me what to look for. I want to look for how many touchdowns, 5, and how many minutes, 15. And it also tells me not only what to look for, but what order to divide in. Because the touchdowns came first, I'm going to write them first, followed by the minutes. And remember, for unit rate, we're going to divide. All right, so when you pick up your calculator and you take 5 divided by 15, you're going to get a repeating decimal, 3, 3, 3, 3, blah, 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 to the end of time. But it says I want to round my answer to the nearest hundredth. Now, hundredths are 2 places past the decimal. So it's okay to have 2 places, but no more. So I'm going to put a cut line right there. I'm going to look at this number right here. If it's a 0, 1, 2, 3, or 4, I'm just going to cut it off and be done with it. If it was a 5, 6, 7, 8, or 9, I would round up. Because it's a 3, my answer is 0 and 33/100 touchdowns per minute. In everyday life, we can use unit rates to compare. We can decide which of these is the better buy or who is faster. Let's let's start with a best buy problem. Recently on Amazon, I found that I could buy a 144 ounce bottle of Tide for $17.99, or I could buy 100 ounces of Tide for $11.98. And I want to find out which is the better buy. So when we are computing best buy, I always want you to think about price per measure. So start with the money. And since we're talking money, you might have to round to the nearest cent. So on the first one, it cost $17.99 for 144 ounces. And for unit rate, I'm going to divide. And so I'm going to let you do that. You should have come up with kind of a crazy decimal. 0.124930556. That's a long decimal. All right, let's try the next one. The price is where I'm going to start. So I'm going to start with $11.98 for 100 ounces. And remember, I'm going to divide because it's unit rate. I'll give you a second to do that on your calculator. And you should have come up with a less crazy decimal. And I want to know which is the better buy. Which one is cheaper? Now, normally I would go ahead and round those. But if you do that, you're going to find out they're both going to round to 12 cents. So let's just look at it for a second. This first one right here is 12 cents and a little more. And the second one is a little less than 12 cents. So I want to go the cheap route. And so I'm going to say that the better buy is the 100 ounce because it costs less than 12 cents per ounce. So this time we're going to buy toilet paper. So I'm at Walmart and I see that I can buy 72 regular rolls of Angel Soft toilet paper for $15.97. Or I could go the Charmin route and get 64 rolls for $14.97. And I want to know which is the better buy. So I'm going to start with the price. Now let's do Angel Soft first. So the Angel Soft costs $15.97 for 72 rolls. And I know I have to divide those because it's unit rate. So I'm going to give you a second to do that on your calculator. All right, you should have come up with a long decimal again. 1805556. And if we do the same thing for Charmin, we're going to start with the price. And we're going to divide it by how many rolls. I'll give you a second to calculate that. And you should have come up with this. All right. All right, so we're talking money. And so we can have 2 decimal places, but no more. So it looks like Angel Soft costs 22 cents per roll, while Charmin costs 23 cents per roll. So I'm going to say the better buy, since we want to go cheap, I'm going to say Angel Soft is the better buy because it only costs 22 cents per roll. All right, let's talk about which is faster. So we can use unit rate to compare speed as well. So Usain Bolt can run the 100-meter dash in 9.58 seconds. Kingston Rule, which is a racehorse, can run 120 meters in 7.32 seconds. Which is faster? Show your work. Well, we probably could use mental math and good number sense to help us, because obviously Kingston rule is going further in less time, so it must be going faster. But it does say to show our work. So let's think through this one. It doesn't say any kind of a label for us, but I want you to think about speed. So speed is usually distance per time. So for example, miles per hour, or in this case, meters per second. All right, so we've got meters per second. We've got 100 meters and 9.58 seconds. So I'm going to do my meters for Usain and my seconds. And because it's unit rate, we're going to divide. Give you a second to work that out. You should have come up with 10.438413336. It's kind of hard to read. Meters per second. And then let's go ahead and do Kingston rule. Meters per second. I have it in the right order. You're going to go ahead and divide. And you should have come up with 16.39344,262 meters per second. And our answer is Kingston rule, because he runs about 16 meters per second compared to Usain running about 10 meters per second. This one is a jogging trail problem. It says one day I ran, well, it says run, but I want to change that to an A. Ran a 1.5 mile trail in 14 minutes. I know I'm going to need that information, so I'm going to go ahead and underline it. The next time I ran, I tried a 2.5 mile trail, and I ran it in 22 minutes. On which trail was I faster? Show your work. All right, so I'm going to do distance per time. So my distance on my first one, I like changing these into decimals just because that's easier on my calculator. Now I know you have a fraction key on your calculator, so you don't have to change it. It's just easier for me. So I ran 1.5 miles and I ran it in 14 minutes. So if I take 1.5 and I divided it by 14 minutes, that means that I was going at this pace. 107.142.857 miles per minute. All right, on the second trail, my distance, 2.5, and again, I'm going to use the decimal form, divided by 22 minutes. I'm going to give you a second to do that. And you should have come up with this, 3636364, same label. All right, so now I need to compare these. Now, if I compared the 10th place, they're the same number. If I compared the 100th place and I rounded, I'd get the same answer again. So let's use a little bit of common sense instead. So on this 1.5 mile trail that I have in red here, it would round to 1100ths, but it's a little less than that in reality. On the blue trail, my 2.5 mile trail, it would also round to 1100ths, but in reality it's a little more than that. And so when I want to know which is faster, I really want to know which is the bigger number. So I'm going to say the second trail was faster because I ran more than 1100 miles per minute.